So this is the top level module connecting all the sub modules. The neural network has inputs, clock, enable, reset, and your image, your output, your NN done, which is asserted when your max done is 1. So the pooling average pooling layer, instead of writing it as a module, I have integrated that as a simple code inside the neural network top module. So this is basically computing the address, doing the pooling. After the pooling is completed, you move on to dense 1 layer. So dense 1 layer output is computed. Once the dense 1 is finished, that means once the pooling is finished and your dense 1 layer output is computed, you can say that dense 1 enable is 1. Dense 1 enable 1 means your layer 1 uh, business is over. You move to layer 2. Now layer 2 output is computed for 10 neurons, and when pooling is if pooling is completed, if your layer 1 is completed, if your layer 2 is also completed, this means dense 2 enable is 1. Dense 2 enable tells you that layer 2 ka business is also over. Now you move on to the max layer. Max layer is basically taking the output layer as input. It is computing the maximum, and when this finished dense 2, that means layer 2 computation is over and your max layer is also computed. This is when you enable this max enable to be 1. This means your maximum is also found, and then you pass the digit, whatever predicted digit is given as an output from this max layer, you pass this as the final output, and your digit is also recognized, and the done for this entire neural network is asserted, indicating that okay, my computation is being done and the digit is predicted. So we'll look at the test bench and we'll look at the output. We'll look at the inputs also. So we'll see what digit we have predicted for our given test data. So this is the test bench. In the test bench, I have a test data B and test data A. So see, the test data is of 784 pixels, because we have seen 28 cross 28, 784 pixels are the total pixels, and the values are between 0 to 127 in this case. 0 to 127. Initially, I told you that the values were between 0 to 255. In the Python script which I have used, so from that Python script, your 0 to 255 is being normalized to 0 to 127, just for the sake of saving more, like reducing the number of bits to save the test data. Okay, and 8 bits. In order to store that test data within 8 bits limit, it's better that you change that 0 to 255 range to 0 to 127, just for the sake of simplicity and saving memory. And this test data is being obtained in this pixel values are being obtained again using the Python script, that whatever pixel is being obtained from the data set, that is converted to your 0 to 127 pixel image, and that array is being given here. So for my first case, I am calling my neural network, instantiating my neural network. I am first giving my clock to be 0 and enable as 0 and reset as 0. And then I pass on my test data A as my image. So my test data A for now I'm saying, see, so this test data is basically 3 and test data B is 4. This is obtained from the Python script, and this test data A is 3. So let's see whether 3 is predicted or not. So then after 145 seconds, I enable this as 1, and then I monitor the values, and so this is basically my clock period. After every 10 nanoseconds, my clock will toggle, and after this much timestamp, my finish will be asserted. So let's look at this. So this is the output that I obtained. So clock was 1, enable was 1, enable is 1 and reset is 0 at time stamp 145 nanosecond. At 145 nanoseconds, we have seen that enable was set to be 1. So when enable is 1, we see that my predicted output, as soon as my enable is 1, my image is being given as an input, and your output is also predicted to be digit 3. See, clock is 0, enable is 1, reset is 0, and digit is predicted to be 3, because my input was test data image A. Now let's give test data B as my input. So I've given my input to be test data B, and I'm running the simulation. Let's check what is the digit it has predicted. Okay, so the digit it has predicted is my enable is 1, my digit out predicted is 4. If I zoom this a little bit, okay, this is, yeah, digit out is 4 now, as you can see. My clock and reset is also 1, digit out is 4, and my enable is 1, and my reset is 0, and clock is also 1. So this, yeah, we are getting the correct output, because we have told earlier that digit test B was supposed to be 4, and your test A was supposed to be 3. So we have seen those two outputs. So our module, neural network module, is working fine. We can also build separate test bench module to test your see, average pooling module test bench can be built to test the average pooling layer, dense 1 TB, dense 2 TB, select max TB. So separate TB files can be written down, and then for each module separately also you can check it out. But this was the TB for the entire neural network, and we are getting the results as expected. So yeah, so that was the complete project. I hope you have enjoyed it. Thank you.